Right, so we've got a vehicle of mass 5,000 kilograms moving along the road. So you can see here I've got all the horizontal forces labelled. Okay, so we've got the resistance here, as it says, of 1500 newtons. And then of course there's the forward force, which we call the tractive force, which is created obviously from the work that the engine is doing. Okay, so we call that the tractive force, the force that's pushing it forward. And what we can do is apply Newton's second law to this in the direction of motion. Okay, so we can see on my diagram is moving to the right. Okay, so with Newton's second law, we know of course that the resultant force equals to mass times acceleration. Okay, now the resultant force in this case, well, you've got tractive force pushing it forwards, and then of course then you've got to subtract then the resistance of 1500 newtons, and that will equal to the mass, which is 5,000 times the acceleration a. Okay, so we've got an equation here which we can work with throughout parts A and B. So in A, it says find the power which is developed at the instant when the speed of the vehicle is 12. So when v is 12 and the acceleration is 0.2. Okay, well, using Newton's second law here, right, I can obviously use the acceleration value in there to work out what my tractive force is. So sub into 1, so we have tractive force, take away 1500 equals to 5,000 times 0.2. Okay, so then you have tractive force, take away 1500 equals 5,000 times 0.2 is 1,000. So therefore the tractive force will be 2,500 newtons. Okay, now that we know tractive force, we can work out the power because we know a formula for power. So the formula for power is the tractive force times the velocity of the engine, right? So in this case we know the tractive force now is 2,500 and the velocity is given to us as 12. So if we work that out, then we get 30,000. Of course, power is measured in watts. Okay, or you can write that as kilowatts. Okay, so 30, because it's 30,000, so it'll be 30 kilowatts. Okay, so then in part B, it says the maximum power of the vehicle's engine is 45 kilowatts. Calculate the maximum speed of the vehicle along the road. Well, if you think about it, right, at the maximum speed, okay, can't go any faster. We know, of course, that acceleration will equal 0. Yeah. Okay, that's always the case at max speed. The speed is hit its max, and it's not slowing, it's not increasing, it's at a constant. So the acceleration will be 0. Also, because it's at its max speed, of course, the power will be at its max. Okay, so the engine's working to its max capacity, so that will be 45 kilowatts, which is 45,000 watts. Okay, but if you go back to equation 1, okay, because the acceleration is 0, you'll have tractive force take away 1500. 5,000 times 0 will be 0. So therefore the tractive force will simply equal to 1500. Okay. So then you go back into your power formula. Okay, so using the power to equal to the tractive force times velocity, well, we know the power is 45,000. We know the tractive force is 1500. So it's a case then of working out what the velocity is from there. Okay, so rearrange that equation. Velocity will be 45,000 divided by 1500, and that works out to be 30. So 30 meters per second.